So we're given f of n is equal to ln of n plus 5n squared. And we want to show that this is big O of g of n, where g of n is n squared. Okay, so another way to think about this is we want to find some capital M such that f of n is less than or equal to m times g of n. And if we divide both sides by g of n, we have f of n divided by g of n being less than or equal to m. So if we can find m, we're good to go. So this is how you want to do it. F of n is ln of n plus 5n squared. G of n is what we want to show here, n squared. Okay, so we want to find something bigger. M is going to be a nice number. Okay, so what we see here is there's three terms, and two of them are in terms of n squared. So can we find a bigger function of n squared that is bigger than ln of n? So let's look at a graph to convince you of what's happening. Okay, so here's ln of n, and here is is n squared. If you look at the difference between n squared and ln of n, well, n squared is always bigger than ln of n. So if I want to find something bigger than ln of n plus 5n squared, I can say that n squared is bigger than ln of n, and then I'll just keep 5n squared the same. And then I'm going to divide everything by n squared. N squared plus 5n squared is 6n squared. That's over n squared, which is 6. Okay, so we showed that f of n is less than or equal to 6 times g of n, and thus f of n is equal to big O of n squared, or g of n in this case. Okay, so this one is done. Okay, now what if we're given a different function? Now what if f of n is equal to n plus 1 choose 2. So another way to write this function is n plus 1 factorial over 2 factorial times n plus 1 minus 2 factorial. I can rewrite this as n plus 1 factorial over 2 times n minus 1 factorial. N plus 1 factorial, we can break it up into n plus 1 times n minus 1 factorial. The n minus 1 factorials are going to cancel, and so I'm left with n plus 1 times n over 2, which is n squared plus n over 2. Okay. So I really simplified this into a nice function. So now I want to show that this is big O of n squared. So recall, I want to find some capital M such that f of n is less than or equal to m times g of n. In other words, the ratio f of n over g of n is less than or equal to m. So f of n was given by n plus 1 choose 2, which we simplify to n squared plus n all over 2. And then g of n is n squared. So the idea is, can I find something bigger? And here we have 2 n squareds and 1 n. The constant 2 I could just pull out. You know, I don't really care about it. So to help you out, you can just think of it like this. Oops. N should be in the denominator. Okay. So we can rewrite n squared plus n over 2 over n squared as 1/2 times n squared plus n over n squared. And I want everything to be in terms of n squared, right? So if I want to find something bigger, is n squared bigger than or equal to n? let's kind of convince ourselves. Well, okay, this is not a good picture here. It's briefly smaller from 0 to 1, but other than that, it is bigger. So, for n big enough, yeah, n squared is bigger than or equal to n. So we can have n squared plus, and then we're going to replace n with n squared. And then we're going to divide that by n squared. And don't forget the 1/2 in front. So this is equal to 1/2 times 2n squared over n squared, which is 1/2 times 2, which is 1. Okay, so this is m. M is equal to 1. And so we say that f of n is less than or equal to g of n, and thus f of n is equal to big O of n squared.